Hi there. Welcome. Today we're going to discuss finding the maximum subarray using divide and conquer, presented by Ayusama. Table of content, we're going to discuss defining the problem, why divide and conquer, steps for solving the solution, coding of the solution to the problem using Python, time analysis using recurrence, comparing it to other algorithms, and why choosing the right strategy is important. Now, defining the problem, what we do have is that it's probably it's an array that we will get, and we should probably find the maximum subarray that brings us the total, like the combination. If we add these parts together, this is the solution, then they bring us the maximum number, which is 9. Any other ranges that we take will probably give us less number. Now, why divide and conquer? Divide and conquer isn't something new. It's been used throughout history by great generals like Sun Tzu, the author of Art of War. Now, how does it actually work, the divide and conquer? We have the problem, and then we're going to divide it into two halves, subproblem right, subproblem left. And then we're going to find each problem, we're going to find its solution, and then return both and combine them, and we get the solution of the problem. In a brute force method, what we're going to do is that we're going to take the first element, for example, and then keep on adding it to the next elements behind it. And then the next element, which is -2, and then keep on adding and seeing what is the sum of it. And then so on and so on until we find the perfect combinations that give us the maximum subarray. That will be n squared. Now the divide and conquer method is quite a bit different. What we have is going to divide it into two parts, left part and right part. Let's take the left part, for example. We have this part that we divided. We're going to take it and also divide it into another two parts. And then we're going to divide it again into another two parts. And now we're going to start to calculate which one is greater, -1, -2. In this example, -1. So then we're going to return it. Again, for the second one, it's 6. And then we're going to compare both and then return it to the main one, the color. We're going to repeat the same thing for the right part. And then also there is a condition that perhaps it might be in the middle, in ranges between them. So it might be, which we call it the crossing. Then we have three values, the left, the right, and the middle, which is the crossing. We're going to compare the three, and the one that is greater is the maximum subarray. And then we're going to get the ranges. Now let's review firstly how to do the brute force method. Now the brute force method is quite simply making the for loop from here, two for loops we do have, and then it's going to take the first element and keep iterating through the whole array, and the second element and iterating through the whole array, and so on and so forth. That will be n squared, time analysis of n squared. Now a better algorithm that we can try is the divide and conquer. The divide and conquer is basically using recursion. Now here we do have the base case element, where if it's one element inside the array, it's going to return it as the maximum subarray. And then we're going to have the other cases, the normal ones, which is probably going to be the left side and right side, but before, of course, we need to have the midpoint to determine where it's going to start and where it's going to end, and from where it's going to start from the midpoint and where it's going to end. Now both of these are good conditions, but perhaps, as said before, the crossing condition, which is here, that it might be in the middle. Now in case it's in the middle, we're going to have another parameter that we're going to send, which is going to be the middle one. And then we're going to use the same methods again, and then we're going to return with having three things. We're going to return is the maximum subarray of the left side, right side, and the crossing section. Then we're going to compare both of them. And we're going to choose which one is the greater. In this example here, we have the array, and the actual answer is from 6 to 2, with a total maximum subarray of 9. Now this is the time analysis that proves why it's n log n. First, we're going to use the recurrence relationship by actually going and replacing the formula into the one, n-1, and then keep on n-2, and then keep on and repeating that process and keep on repeating until we find a relationship. And then we're going to make a constant out of it. And then we'll find out to sum it up n log n. Now other algorithms to compare with, brute force and Kidane algorithm. In brute force, it's n squared, while in Kidane algorithm, it's only big of n. Why is choosing the right algorithm is important? Because in game development, depends on the algorithm you choose, whether your game is optimized or not. In data analysis and financial data analysis, we have which stocks to buy and which to sell, image processing to identify areas of interest or patterns in the images by analyzing contiguous regions. And here is the sources. Thank you for your time.